Test. Test. All right, we're good. All right. So here's the auxiliary talk, thanks to the weather. Thanks to Shmoo for having me here. Thanks for my screensaver for picking that moment to turn on. Here we go. Got a lot to cover and not much time. So I'm Mike Kershaw. I'm also known as Dragorn. I wrote Kismet, LORCON, some other random crap. Talk to me later. 802.11 networks, 2.4 gig, 5.8 gig, multiple data encodings, but they're all fundamentally spread spectrum. That means we can mess with them easily. I got 100 slides in 20 minutes. It'll be fun. Unlike frequency hopping, it's trivial to capture 802.11. Most people here probably already know that. So, generic Wi-Fi card, 50 bucks, you get to have fun. So, we've got a pretty good idea about 802.11 security by this point. And by we, I mean, the security people, hackers at the con, we're good. But even the great unwashed masses, they're beginning to clue in. I mean, we're up from like 5% encrypted in the general, Wi-Fi world up to, maybe 40%, more in Europe, but. So, Wi-Fi, it's secure and proper deployments. What's a proper deployment? WPA Enterprise, per user authentication, per user keying. You can do mutual auth via certificates. It's good stuff. We've got a pretty solid crypto on Wi-Fi now. AES is still unbroken. TCIP is showing flaws, but it was supposed to die by now anyway, so move to CCMP, upgrade your WPA, you'll be fine with there. So, done properly. It's only secure if you do it correctly. Sure, opportunities exist for messing with users. Josh Wright gave a talk a couple years ago here at Shmoo about that. If users are allowed to say okay, then they're going to because they really want internet. And eventually TCIP's going to fall down. So, we've been doing AP defense for a long time now. A lot of people are saying, Wi-Fi security is dead now because we already have it all covered. Well, kind of. So, best defense, strong network architecture, use WPA. You can monitor for conflicting access points. It's easy to defend clients because they're connected to you. You can watch them connect to other APs, kick them off, and bring them back. Inter-client traffic can be blocked at the AP when you have a secure network. Defending clients on a strong network is easy since the AP controls the crypto. Defending clients on an open access point, on the other hand, is very, very hard. Management frames are all unprotected. You can spoof the access point, tell the clients to disconnect. You can denial service them. Denial of service attacks are pretty boring. Pretty much the only defense against them, crowbar, find the person with it, hit them with a crowbar, denial of service problem goes away. But, I mean, other than that, yeah, you can be a big pain in the ass, but denial of service isn't very fun. So, what is more fun? Well, punching 802.11 in the gut is ridiculously easy. Management frames are completely unprotected. Open networks are unauthenticatable, and it's shared media. You can't validate you're talking to the AP. The AP can't really validate they're even talking to you. Avoiding hostile open networks requires really smart users. Users are typically not very good decision makers. The operating system doesn't help. Oh, I've seen that network before, I'll join it again automatically. It's hard to tell what one's a real network, even if you look. Users like free Wi-Fi. Who wouldn't want to join free public Wi-Fi? I mean, I imagine by this point, everyone has seen free public Wi-Fi. Long ago, this network probably existed. Windows up through XP Service Pack 2, and I think Vista did it a little bit. Anyway, when they can't find a network, they just, I'll just make an ad hoc version of the same network. I don't know the logic behind why they think an ad hoc network that goes nowhere is a good solution to I can't find my real network, but they do it. And then someone else tries to join it, and now that's in their preferred network list, and they go, oh, I can't find this network either. I'll make an ad hoc network of it. And then someone else goes, I'm going to join that. I like free public Wi-Fi, and on and on. Of course, that doesn't go anywhere unless, someone brought up a network called free public Wi-Fi and handed out IP addresses, but that would never happen, right? I mean, no one would ever think to do that. So it works because clients are really trusting. If you say you're foo, you must be, right? I mean, it's obvious. Of course it's linksys. Roaming sure looks a lot like spoofing. So what's roaming look like? Roaming's multiple APs with the same SSID. Client assumes the strongest SSID is the nearest one. Roams the strongest signal. Data handoff hangs out in the background, and the only differentiator is MAC address. Do you really think users are going to check the MAC address? They're not. And the drivers are just going to roam automatically because a spoofed AP looks like roaming. So if attacker has a stronger radio than the AP, you might not be talking to who you're thinking to. As long as the packets are going through, you might not even notice. A random user definitely won't even notice, and you win at man in the middle. Yeah, so you just bring up a 3G network and free public Wi-Fi, or rhymes with Farducks, or Hackdonalds, or so many sites will support encryption. They'll encrypt the login, but they won't do the session. Google was guilty of this until very recently. So you got the middler, you got SSL sniff, you got Cookie Monster, hijack sessions with man in the middle. But all this is pretty boring. They're really obvious. If you're spoofing an AP, you're going to be noticed. I mean, okay, so probably Starbucks won't notice you, but still. I'm going to say points are awarded for style, and it's great. I get to give the talk and then award myself my own points. So, didn't we say, wait a minute, 802.11 is shared media. So we found the best time machine ever made. It's not a hippie do-gooder time machine, and every time this slide screws up and I think I fix it. It's supposed to be the TARDIS. Laugh as if it was. See? All right, so not only that, but it's a time machine where we get to bring back awesome weapons from modern day. So, bad old days, well, 1990, everyone had, hubbed Ethernet, bad grunge bands, and, shared media and TCP session hijacking on your college dorm LAN. But, it would never be that easy, right? People have gotten smarter by now. You'd never take a system from a secure corporate network and put it on an insecure network somewhere, would you? You'd never take your company laptop somewhere. So, management frames have no protection. Open networks have no means to protect their clients. Nothing stops us from spoofing the AP and talking directly to the client. You can try to filter that and say, well, you're from a client MAC address and a client MAC address. I'm not going to allow it. But all we do is generate an 802.11 header, say we're from the AP, we're to the client. The client thinks, oh yeah, it's totally my AP, because it's not encrypted. They don't know. AP has no opportunity to act on it because they're not getting the packet. And we can, break past the whole protected thing on open networks very easily. So, making this a lot easier. Josh and I gave a talk on this years ago, but this is better. So, writing the same injection code for every app sucks. Every app had to do, all the maintenance code. It sucked. Writing custom code for every driver sucks. So you'd have to rewrite your app for every driver. You have to rewrite your app for every operating system. Hopefully, LORCON, this library we built for injecting, doesn't suck. Unfortunately, it kind of sucked. So now there's LORCON 2. The new API is modeled off PCAP. It's designed to be really easy to use. You get C and Ruby and APIs. It'll soon support all the cards LORCON 1 did. Right now, it's just Linux kernel drivers. URL will be at the end. So it's super simple, automatically determines the driver for you now, automatically configures the network interfaces for you, sets up virtual interfaces if you need it, send arbitrary bytes or do packet assembly. There's a bunch of examples online. So the inspiration for all this fun, here's where we get into the really depressing part. Wi-Fi session hijacking. About 5 years ago, Toast did Airpone at DEF CON. TCP stream hijacking over 802.11. This is really friggin' awesome, and no one has noticed it. Everybody kind of forgot, because it's not just for shock porn anymore. If you don't get it, ask the person next to you. They'll be more than happy to explain it. So what are we doing? It's a typical layer 2 attack. So TCP is only secure because the sequence number and ACK number aren't known. If I see your layer 2, then your sequence number is very damn well known to me. So any TCP stream is subject to creative abuse. So what's it normally look like? Handshake, client, ACK, SYNAC, whatever. SYN, SYNAC. So client server gets a URL. Some sequence number, some ACK number. Server says back, here's the headers, here's your content, and agreeing with the sequence and ACK number in the stream. So, let's make this a little more fun. Let's add a LORCON Ruby wrapper and implement this in Metasploit. So what does it look like now? Handshake, TCP, ACK, etc. Client says to the server, give me this. Metasploit and Airpone say to the client, here it is, right in line with your SYN and ACK. And since I'm right next to you and your server's in California, I win. And then I said to the Metasploit says to the client, and you're done, so stop listening for more data. And it says to the server, you're done, stop sending more data. I'm the client, trust me, you're done. And it says the server might, packets might come through that were stuck somewhere, but they're out of sequence now, and the client goes, that's crap, throws the TCP packets on the floor. So since the demo gods never smile, you get a courier font and pasted text for a demo, but we only have 10 minutes, so that's fine. So how simple is it? Set the interface, set the response you want, and let it run. And there it is. It works. It's in Metasploit already. Pull the latest version. I think it was in the last release too. So what can we do? We can do match and replace using regex in Metasploit for the URL catching. Response can be JavaScript, image replacement, HTML, some file off your file system. There's a YAML config file.